Okay, so Pythagoras Theorem. New topic is our trigonometric and right angle topic. I'm going to start off by looking at something that we've seen since year 8. Okay, so the side opposite a right angle in a right angle triangle is called the hypotenuse. Okay, so here's our right angle down here. So the side opposite is just called the hypotenuse. It's nothing tricky about that. It's just wherever the opposite side of the right angle is. It's called the hypotenuse. It's also the longest side. Okay, so the longest side is the hypotenuse. Now, Pythagoras' theorem itself says that the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the other two sides. So all this is saying is, if you were to make 3 squares that were as long as the side, so if these are all, actually straight, and I actually had space to do it, then if you added, so this area here, so let's say, whatever, so if you added this area here and this area here, you would get the same as this area here, okay? So basically by making squares, you'll get the area the same, and that is true for all right angle triangles. So when we're talking about the lengths, they're not always going to be whole numbers, okay? So we might actually be given a number that is or what is called a surd. So it's a number that keeps going on forever and ever. So numbers that look like surds, and you guys have seen these before in quadratic equation things. So examples of surds are square root of 2, square root of 28, and 2 square root of 3. And they're all examples of surds. Now, when expressed as a decimal, a surd is a non-terminating, non-recurring decimal with no pattern. Okay, so that just means that if you were to try and find the pattern for it, you can't, because there is actually no pattern for it. So, for example, square root of 2 is equal to 1.4142135623, and that should say ... because it actually keeps going. But if you put it into your calculator, it might only show that many numbers. But no, it does keep going. Okay. So a Pythagorean triad is a set of 3 numbers that can be used to form a right angle triangle. So we've got 3, 4, 5, 6, 8, 10, and 5, 12, and 13. Now you notice between the first two, these ones here, that actually they're just double the sizes of the triangles, okay? So basically, if we were to make a square on each side of these, okay? So this one is 3 by 3, this one was 4 by 4, and this one was 5 by 5, okay? So the area for this one, so area is just timesing the two together, we get 9. Area of this one is 16, and the area of this one is 25. So is 9 plus 16 equal to 25? And it is, so that makes it so that this is a right angle triangle that exists. Okay, you can do that to all 3 of them, and we'll be doing that a bit later on as well. Okay, so now we're looking at the examples. So this is basically how we're going to answer these questions. So, example 1, state the length of the hypotenuse of these right angle triangles. So basically, you've just got to find where the hypotenuse is and what number is with it. So for this one, it's a number that goes across from the right angle, so it's 5. So the hypotenuse for this one is 5. For this one here, it's just the one that goes across, so it's 10. So the hypotenuse is 10. And for the last one, a little bit different, goes across here. Hypotenuse is 13, and that's it. Okay, so next we're going to write down Pythagoras theorem using the given pronumerals, or numbers in this case, for these right angle triangles. So I'm going to do a 4th one on top of this, but for these 3, basically all we have to do is we're going to say that the hypotenuse, so 5 squared, is equal to the other 2 sides, or the sum of the other 2 sides squared. And that's all we have to do for this part. So for this one, the hypotenuse is 10, so we're going to write 10 squared is equal to the other 2 sides squared added together. So this one, last one, so 13. So 13 squared is equal to 5 squared plus 12 squared. Okay. And sometimes you might not just be given numbers, you might be given let's not use A, we'll use, let's say, not Z either. Let's go. Whoop. Oh my god. T, Q, and R. So this one is, so what's the hypotenuse? Well, in this case it's R. So R squared is equal to, that's a Q, not a 9. Q squared plus T squared. Okay, so after that, we're going to answer a question like this. So question 3 looks like so basically it's just an explanation of what to do. I think the question is, what are these surds equal to? All you have to do is put them into your calculator around to 2 decimal places. I don't need to do that for you. You should know how to do that. Literally just put the square root button and then a number in, and then press equals, and then round to 2 decimal places. That's it. Like, there's nothing hard about that. Okay. Questions or examples from 4 to 6. So find the length of the hypotenuse in each of these right-angled triangles. First in the exact form, and then to 2 decimal places. So basically, we're going to work out what this length is. So Pythagoras Theorem actually helps us to work out what the lengths of a triangle may be. So we've got x and x there. So what we're going to do is we're going to write down our Pythagoras Theorem. So we're going to start off with that. So we're going to do x, so the theorem itself is c squared is equal to a squared plus b squared. Okay, so whenever I'm doing a Pythagoras problem, I always start out by writing down the formula. Okay, or the theorem. So I'm going to do that on both of them. Now, I need the hypotenuse. So the hypotenuse is the side that's the opposite. So the c is actually going to become x. So x squared is equal to. Now, it doesn't matter which way I put the 10 and the 24. Okay, because when I'm adding two numbers, it doesn't matter which way I do it. Okay, and once we've done that, we can go, so now it's just solving the equation. So it's solving a quadratic equation, which is what we did before we broke up from term. So x squared is equal to 10 squared plus 24. So x squared is equal to, well, what is 10 squared plus 24 squared equal to? So we're going to put it into our calculator, and I'm sure you can beat me to that because it's 676. Okay. Now, to get the x by itself, I need to do the opposite of squaring, as we remember is the square root. So x is equal to the square root of 676. Now, this here is the exact form. Okay, so when we leave it as a surd, that is the exact form from up there. Okay, so that's the exact form. And then to round it to 2 decimal places, so x is equal to the square root. I'm going to have to get my other calculator for this one. So the square root of 676 is equal to 676 square root is 26. Okay, so that one was good because we didn't actually have to round it. So that was the answer to correct 2 decimal places, just 26. Now doing the other side, number B, I've already written down the formula, so then I'm going to say, okay, well, the side that's opposite is that x there. So x squared is equal to. Now, again, it doesn't matter. I could put the 8 first and the 4 second, or the 4 first and the 8 second. I'm going to do the 4 first and then the 8. So x squared is equal to, so 4 squared plus 24. 4 squared plus 24. So 4 times 4 times 4 plus 8 times 8 equals 80. Okay. Now, to get the x by itself, I'm going to do the square root. So if x squared is equal to 80, then x is equal to the square root of 80. And again, this is the exact form. Okay. And last but not least, we're going to work out what it is to 2 decimal places. So putting the square root of 80 into our calculator, we get x is equal to, now it's 8.94427, blah, 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 blah. So rounding it to 2 decimal places is just 8.94. Okay. So that's how you find the long side of a right angle triangle. Okay. Now, question 7 is very similar, but with a little twist. What we need to do is we need to convert it into the units that is shown in red. So convert to the units indicated in red. So for this first bit, I've got 62 millimeters is my red, and I've got 4 centimeters. So I need to change my 4 centimeters into millimeters. So 4 centimeters becomes 40 millimeters. Okay, so if you forget how to change millimeters to centimeters, you just times it by 10. Okay, or in other words, there is 10 millimeters in 1 centimeter. So in 4 centimeters, it'd be 40 millimeters. Okay, now we're going to actually work out what that side length is equal to. So we're going to start off by writing my formula. C squared is equal to A squared plus B squared. Okay, now I'm going to start with the hypotenuse. Well, that's the side that's going across. So x squared is equal to... Then I'm going to put my two sides in, remembering to do my millimeters. It's going to be 62 squared plus 40 squared. Now this one is going to be much bigger than the ones that we've done before. So 62 squared plus 40 squared, and that's equal to 5,444. Okay, now with 5,444, we need to get the x by itself. So to get rid of the x squared, we're going to square root. So the opposite of squaring is square rooting. So x is equal to the square root of 544, or 5,444, I should say. So doing the square root of that gives us that x is equal to 73.78 to 2 decimal places. So remember that this one is the exact form, but it's asked us to round to 2 decimal places where necessary. So in that case it was. Okay, just as a little general rule of thumb as well, this number here should be bigger than the other two. And it should be bigger than the other two because the third side, or the hypotenuse, is the longer side, so it should be longer than the other two. Alright, last but not least, we're going to calculate the length of the hypotenuse and then find the perimeter. So to find the perimeter, we just add all the sides. That's it, nothing tricky about that, we just add all the sides. But before we can add all the sides to this one, we actually have to work out what this one is equal to. And to do that, we're going to do Pythagoras. So starting off by writing out our Pythagoras theorem. C squared is equal to A squared plus B squared. Okay, so once we've done that, we're going to substitute our values in. So my pronumeral in this case, is x. Now, it might not always be x. It might be an A, or it might be a C, or it might be an F, or Q. It could be anything. But we just use x for simplicity's sakes. 2 squared plus 10 squared. So x squared is equal to 2 squared is 4, and 10 squared is 100. So 100 plus 4 is 104. Okay, then what we need to do is we need to get the x by itself. So we're going to take the square root of 104, and that gives us 10 point... now it's 198. Now to round this to 2 decimal places, it's 10.20. Okay, so because we want to do it correct to 2 decimal places, okay, I'm going to round everything to 2 decimal places. So what this is saying is that this x up here is actually equal to 10.20, or just 10.2. So to find the perimeter, so P is equal to, all I need to do is just add the sides together. So that my perimeter in this case is equal to 22.2 centimeters. That's it. So again, it's just using Pythagoras' theorem, but the only difference is that you are then having to just add it on to the other two sides for the perimeter. Okay, so it's pretty easy. So question 9 onwards is consider extension. It's not required to be completed, however, it would be worth your time to attempt it. So what I'm saying is you don't have to do it. Okay, so there should be more than enough questions for you to do, and we only need you to do up to question 8 anyway. Other than that, that's pretty much everything that we need you guys to do. And there aren't actually that many questions for you guys to do for this one, so that's always a bonus for everyone. So with that being said, I will see you guys in the next video.